correct, you have to see its precondition and postcondition. It's never relative. It's never absolute. It's always relative. So now, the key idea for the whole lecture is to prove the correctness of the program for iPhone or for any, or even for your Java. So basically, you have some require here, and then you have some precondition here. You have some implementation here, ensure. Over here. The idea is to actually prove that this fragment of code is actually correct. We transform that into some predicates. So we transform that into, let's make some example. Let's say if you say x greater than 0, let's say decrements. Okay, x greater than 0, x is decremented. Ensure x still greater than 0. Okay? How do we prove that if this program is correct or incorrect? How do we do that? So somehow we transform this into predicates. It's called a or triple. So here we have, so this is the syntax. So there are three things you gotta fill in over here. So you gotta fill in the precondition, you gotta fill in the postcondition, which are the specification for the program. So you gotta put the implementation body into them. Okay? So now x larger than 0, then the same, x larger than 0, precondition and postcondition here, and the body implementation is simply x minus 1. Okay? This whole thing here is a predicate, which means it's either true or false. That's really the big picture you have to always remember. That's what we are trying to do. Of course, the program here, this is a simple case. We simply have the assignments. In the more complicated case, we might have some if then else, we might have some sequential composition. So what I mean by sequential composition, in iPhone, you don't actually have the semicolon here, but whenever you have a new line of code, you're really saying, execute this instruction first, and then do this one, and then do this one. That's really sequential composition. It's like a semicolon in your Java code. And also you have loops, which we'll also talk about in detail today. So okay, and pre and post conditions are Boolean predicates, as you know very well already. So this part, you might have assignments, you might have if then else, you might have loops, then you might have sequential composition. That's a big idea. Now how do you actually know this particular predicate should be true or false? That's something I'll show you. That requires some logical reasoning. That's exactly what we're going to dive into. Okay, so that's good. So this predicate can either be true or false. Oops. Okay, so we also talked about the notion of being weaker or stronger for the predicates. So you can just review the example. I'm going to post some slides early tomorrow morning. Okay, so we don't have to worry about that. So now for logic. So this is where we left off from last week. Okay, let's have a look at this. Actually, we also talked about this. So basically, this is a for triple we're talking about. S is basically your implementation code. Q and R, Q is for precondition, R is for postcondition. And we have a separation concern. First of all, we may want to prove separately whether the code S terminates, and also, given that it terminates, does it establish the postcondition upon termination? So two things we're trying to prove, especially for the loops that we're going to talk about. Invariants are for proving the correctness of your loop. Variants are for proving the termination of the loop. You'll see an example in the slides. Okay, so I'm also going to make a accessible to you, chapter 11. Okay, let's have a look at this one here. So it's actually very similar, maybe slightly more complicated than what I put on board. Let's have a look at this one. That means, given that the clients satisfy n larger than 5, the supplier is going to increment n by 9. And now, supplier is going to guarantee that n will be larger than 13 upon termination. you might just be able to actually see by yourself that this program is either correct or incorrect. Should I be correct or incorrect? You see any problems with this program?
It's correct.
Is it correct? So let's just try to verify that informally. So n should be larger than 5. So n should be starting from 6, 7, 8, 9, etc. So now n plus 9, so 15, and then 16, 17, 18. So all of them seem to be greater than 13. Yep, that seems to be correct. However, let's say if you have something that's actually weaker than this, if you say n should be greater than 3. Would that work?
For precondition?
For precondition, yeah. If I weaken that precondition here by saying n greater than 3.
It doesn't work.
No.
How come?
Because if n is 4, 4 plus 9 is 13. 13 doesn't
It's not greater than
satisfy.
13. Yeah, that's good. Very good. So now, actually, informally, you kind of know how to argue by trying to see if we allow any inputs that shouldn't be allowed. But it's a systematic way of calculating this. Okay, so now, n larger than 4 turns out to be so-called weakest precondition for the given implementation. So first of all, you have to know one thing here. So we're going to use the acronym here. So WP is going to stand for weakest precondition. That means the largest set of input value that we should allow for this particular implementation. Conceptually, if you think of the WP is like a set of possible input value you should allow. If you get something that's actually weaker than the weakest precondition, which means you're trying to allow something over here, then this might just cause the trouble, as we saw over here. Because when we try n larger than 3, then we actually got a problematic value 4, which shouldn't be allowed, right? Okay, so the weakest precondition is basically the set of value that, and one thing you should really know is weakest precondition is with respect to two things. With respect to the implementation here, and then with respect to the post-condition here. So we can actually systematically calculate the weakest precondition with respect to the implementation code and the post-condition. Okay, that's something you have to get clear first. That's something we're trying to do. Okay, now any precondition equal to or stronger than and greater than 4 will still result in a correct program. We just saw that already. Now, let's say now, you're trying to do n greater than 4, because n greater than 4 is actually stronger than n larger than 4. So this is okay. However, on the other hand, we tried this input already. That's actually weaker than the weakest precondition. But how do we calculate that? I'm going to show you now. It's not that difficult. I just want to make sure you get the big picture first. Okay, so now we are actually going to have the weakest precondition here. Oh, so again, this is the big picture. And just read this part, and then it's also very important for you to know. So the most important two concepts for you to know for this lecture, one is for triples. The other one is WP. To decide whether the whole triple you have is true or false, you have to use the weakest precondition. That's the connection here. Okay, so now we have, in general, we have the precondition R, some program statement here, and we have the post-condition Q. So this can be either true or false, right? So the definition is, this is true if and only if the condition that this R here is actually not weaker than the weakest precondition that we can calculate with respect to the S and Q. Okay, let me write it down and then I'll explain. R implies the WP of S. Okay, don't be too terrified by this formula here. If you only look by looking at that, first of all, you can see the way we calculate WP is by passing two arguments. we pass the program implementation S, and we pass the post condition Q. And then we calculate some condition here. That's called the weakest precondition, which means anything that's weaker than that would not be acceptable. Anything that would be equal to or stronger than that would be acceptable. So that's why we have the implication here to say, whatever precondition you have, or you have devised, if that's actually stronger than the weakest precondition, then you are safe. Then your program is considered as correct. Clear so far? Okay. So now let's have a look. So, and as here, we have assignments, we have sequential composition, we have if then else, and we have the loops. And now we're going to see for each one of them, how are we supposed to calculate the WP. So we'll try to, before the break, maybe we'll try to get to assign maybe the first three if possible, or at least the first two. Okay. Assignments is really easy. So first of all, we have some convention here. Remember in IFO, we actually have the old keyword. So here, sometimes you might find it useful because when you're trying to calculate the weakest preconditions, you need the values for the, let's say for this particular variable x, you might need to refer to its old value and a new value before and after the execution. So for the old value, you should simply just put a subscript 0 there. That means x0 is the value of x before the statement s is executed, and x is the new value after the execution. Okay? That's consistent with our keyword in iPhone. So let's have a look. That's the rule. Okay? Let's have a look together. It might look a little bit complicated, but it's not. Very easy. So the rule simply says, if you have some assignment here, x is assigned to this expression here, use general case. After that, you want to establish some post condition R, then this is simply defined as we'll take the same post condition R, and then we're going to do some substitution. We're going to substitute every occurrence of x by E. Okay, let me make some comments to you. So this is the post condition that has to be established okay, and here this means substitute every occurrence of x by its new value. New value E. Okay, that's basically what the rule is saying. Okay, I will give you one example right away. A very trivial example, just to make sure you understand how to apply the rule. I'm trying to calculate weakest precondition for the following program. The program has just one single assignment, which is to decrement the value of x by 1. And after that, I would like to establish the post condition such that x is greater than 0. So what should be the weakest precondition for that? So let's not worry about your intuition. Let's just do the math, just do the calculus. Okay, so this is how you are supposed to write in the exam. Okay, if I ask you to calculate, so this is how you do it. First of all, this is the problem you're trying to calculate, and then you would say equal sign, angle brackets, and then here you give your reasoning for the next step. That's basically how you do the proof for your math course. So you would say rule of WP for assignments. Okay, so we simply apply the rule. So over there, R is simply just x greater than 0. Agree? Okay, so here I'm saying this is R. So now I'm going to do some substitution here. I'm going to substitute every occurrence of x by its new value, which is x minus 1. How do I do that? Okay, and then, so here I can say perform substitution. So now, the only occurrence of x is here. I'm going to replace that by x minus 1 greater than 0. And you can simplify that a little bit, well, if you like to. So you can say some simplification. So you can say x greater than 1. So that means x greater than 1 would be the weakest precondition for this particular implementation to establish this particular postcondition. Anything that's actually weaker than x greater than 1 would be the wrong precondition. Anything that will be equal to or stronger than x greater than 1 will be an acceptable precondition. Let me make it even clearer. So let's say if you have x greater than 1, x minus 1, and then we have x greater than 1, greater than 0. Is this considered correct?
Yes.
All you got to check is x greater than 1 implies x greater than 1. Is that the case? Yes. On the other hand, if I say x greater than 2, okay, to answer this question here, you have to check to see if x greater than 2 is actually stronger than x greater than 1. Is that the case? It is, right? Because that's indeed stronger. Okay, just give you a counter example here. If you say x greater than 0, for example, and then here. Okay, so now if you're trying to prove to see x greater than 0 implies x greater than 1. That's not the case, right? Because if x happens to be 1, then 1 is certainly not greater than 1. So make sure you understand these three cases for this particular calculation. Again, don't lose the big picture. What we are trying to do is you're given, let's say you're given this particular Hoare triple. You want to say whether this particular program is actually correct. To do that, you have two steps to do. First step, you have to calculate the weakest precondition for this particular implementation here with respect to this particular postcondition. Calculate that according to the rule, and then whatever weakest precondition you get, you'll try to compare that one with your original precondition to see which one's stronger. If the weakest precondition happens to be stronger, then you're in trouble. That means you cannot prove that it's correct. Yes.
Can you please repeat the example with x bigger than
Which one? You mean
the first?
the first one? Sure. So basically, you can see that, so x greater than 1, let's say that's my precondition, my own precondition. It just happens to be equal to the weakest precondition. So anything that's equal to or stronger than the weakest precondition is considered as acceptable. That's why that program here is considered as correct. So this precondition here happens to be equivalent to, and this program here happens to be stronger, the precondition. And this precondition happens to be weaker. So that's why that's not true. Okay. Please make sure you don't get lost because we do have other rules to say. Please make sure, this is a very simple example. I want to make sure you don't get lost before I continue. Yes?
What's the second last line there before x greater than 1?
So, you mean
No,
here or here?
Left side, left side. Left,
Oh,
yeah. The second last line.
second, oh, here? Or just say simplification.
Simplification.
Yeah, I'm just trying to move the -1 to the other side.
Excuse me. So in the final shoot, is this means I need to follow those 3 steps to use like this kind? if I lose like I just say x greater than 0 and x.
So if you apply that, I will accept if you can say up to here. You can write up to here. If you don't have the simplification, that's fine.
Oh.
If you can go up to here and then you say, compare this with the original precondition here, this is actually weaker. That means the program is not correct. Then I would expect you to say something like that. So step 1 is step 2. Step 1 is to calculate a WP, and step 2 is compare the WP you calculate with the original precondition. Okay? Yeah.
Over the parts of the word, x greater than 1 is the weakest, and then x greater than 2 is the stronger than that one, and the third one is the weaker than the.
Yes, that's correct. That's correct.
And you have to write for every.
Oh, actually, it depends on what depending on what I give to you. I might think, okay, there are different ways I can ask you in the exam. For example, I might give you this one only. I say, given this or triple here, I justify if that's true or false. Okay, to actually justify, first of all, you have to calculate what's the weakest precondition with respect to the implementation and the post condition. And then you will do the following calculation, and you get x larger than 1. And step 2, you're going to compare x greater than 1 with the x greater than 1 here. It happens to be equal. So you can say, because they are equal, so this program is considered as correct. Because, let me just show you here. Remember in the previous slides, hopefully that particular formula makes more sense now. So I said, this for triple here is correct if your original precondition here implies the WP we calculate. So basically, this is step 1 to calculate WP. The implication step will be step 2. Okay? It's always the same 2 steps for all the programs. Yes.
Over here, for the simplification, we came to x greater than 1. So that is what we have here already.
Yes.
So why are we doing the x greater than 2 and x greater than 0?
Oh, I'm just trying to show you different examples, basically.
But what if we come to something that is not equal?
Oh, then you have to argue to see if that's stronger or that's weaker. So, okay, that's a very good question. So let's say you come up with something like this, and then my question was whether this particular program here is correct or not. Apparently, you can see they are not equal. One, this precondition here is x greater than 2, and the weakest precondition there is x greater than 1. They are not equal, right? You agree? So now, if you can somehow prove that this precondition here implies the weakest precondition there, if you can prove, that means this whole program here is correct. If you cannot prove, then no, that's not correct. Are you still confused? Or?
I'm just thinking about how we can arrive at that.
Arrive in where? You mean here? X greater than 2?
Yeah.
Oh, well, actually, okay, there are actually different ways. Okay, very good. So let's say if you're trying to develop yours, let's think about what can be the potential value for you as a software developer. Sometimes you may not have your precondition first. Let's say somehow you just write the code. You just write the code for your program, and then you also have some post condition you think that should be satisfied. So now you're thinking about what should be the appropriate precondition for me to put in the required clause. So now one way to do it is simply just apply the weakest precondition calculation to calculate what should be the weakest precondition for this with respect to that. Once you get the weakest precondition there, certainly you will be absolutely safe to simply put the WTP over here. Sometimes you might find that sometimes it might be too weak. You might want to actually put something that's stronger. Putting something that's stronger than the WP, that's okay. Yeah. That's one way of using it. Okay, so let's go on.
Excuse me. Is this WPSQ is the weakest R means is the
Where?
the WPSQ is weakest R, all right?
Weakest precondition.
Oh.
So it's the weakest, okay, the way to interpret this, okay, that's good. So the way to read this is the weakest precondition for program S to establish the postcondition Q. Any precondition that is stronger than this WP here would be okay. Otherwise, it's not okay. Okay, so please make sure you can at least do that exercise there to really to actually get you started with the WP idea. And then that should be quite easy. Yeah, that's so that one I will leave. I'll have the solution already. I will do something that's more complicated later. So this one is to say I will do some implementation here. X is incremented. The post condition is such that x is greater than OX. So that's why you see the x0 here. So what should be the weakest precondition?
X.
So we'll simply substitute x0 here. Sorry, we'll actually simply substitute x here, all the occurrence of x by x plus 1. That's what we will do. Okay? Let me just write it down for you quickly. So actually this example here is actually good to illustrate. Sometimes you might find it useful to use the x0 to help you with the units. Okay, so we have, so somehow you want to calculate what's the WP, right? That's why I put a question mark there. Okay, so here, of course, you would say WP rule for assignments. That's what you have to say. And then we would say x greater than x0, right? That's the post condition we are trying to establish. So now, what substitution should we make? So we're going to say all the x should be substituted by, so here you got to be careful. Although in the programming statement we say that's x, but that's indeed the initial value for x, right? So you would say x. Okay, that's a trick you have to learn. So now you actually say, doing the substitution here as before. So now, sorry, plus 1. Sorry about that. So then x0 plus 1. So here you will substitute x by x0 plus 1 greater than x0. And what's going to happen? If you try to simplify that, if you remove that from both sides, 1 larger than 0. What's that equivalent to? True, right? Somehow, after simplification, you will simply get true. What does it really mean when we say the weakest precondition is true? That means anything that's equal to or stronger will be okay. That means any precondition you get will be correct, right? Because think about the program. So now you can use your intuition. We are trying to increment x. And we are saying after the increments, x should get a larger value. That should be quite trivial, right?
Is this x? Sorry, is this x0 means the original x value?
It's like OX.
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 Oh, old x.
Like an iPhone. Yeah. Okay, so you actually see that any precondition is okay. When I say false is not okay, I meant false will not be very useful because when you have a false precondition, that means no clients can actually ever call the feature, which is completely useless. But logically, it is okay because false implies true.
Is it including negative numbers?
Yeah, of course. Let's say x is negative 5. Negative 5 plus 1, negative 4, which is a larger value, right? Yeah. Okay. How about that one? You try to increment x, and the post condition should be x is equal to 23. You want to try to calculate this in your mind?
X equal to 22.
How do you do that?
Because with substitution with the x 23 equal to x plus 1, so x should be 22.
Yeah, very good. So basically, the substitution is you substitute this x here by x0 plus 1. So you have x0 plus 1 equals 23. If you simplify that a little bit, x0 equals 22. That is also trivial, right? Because if you try to increment x, and the after value can only be 23, that means x has to be 22 beforehand. I'm just trying to make some dumb example to actually make you, how to manipulate the WP. Of course, you wouldn't get this in the exam. I'll be insulting your intelligence, I think. You deserve something that's much more
Sophisticated.
yeah, that's much more challenging. Yes, that's the word. Okay, anyway, so that's exactly what I said. Aha, so that's the example, that's the exercise for you, please. I'll give you 2 or 3 minutes. That will be something that's the big picture as always. So basically we're trying to say, so withdraw here, withdraw has some parameter here of type integer, let's say, and you simply just do balance equal to balance
minus amount, basically.
minus amount. Actually, that's the implementation for withdrawal. So somehow, before you start your calculation, you have to unfold the definition for withdrawal.
Is there anything that has to do with credit or just withdraw? Like
Just withdrawal. Yeah.
just
So
balance?
let's simplify the case. We only have balance
Okay.
and amount. Yeah, to make it very simple. Yeah, the style is very important to get right. But since that's actually your first time doing the calculation, so I wouldn't. I'll try to be critical, but don't take it personally. So that's something you got to improve. First of all, so what's this word here?
I just say that make a mark that this is the original account balance.
Original account balance.
It means this is I need to make the
That's
you can ignore the org.
Can I?
Yeah, you can ignore the orgs.
Okay, that's fine. Okay, so basically, I can see that the flow is eventually, he actually would get the weakest precondition is going to be equivalent to this predicate here. That is correct. Okay, I'm saying the result is correct. By the way, Jim derived that is problematic. I'll show you why. Okay, it's just a matter of style. And then let me just get a big picture right. If he was trying to calculate the weakest precondition, he got some predicate simply account the balance larger than amount, which is different than the original one. So the original one actually has the equal sign over there, which means the original one is weaker because it includes the possibility of equal. So he basically said the weakest precondition is actually stronger than the original one. That's actually saying the same thing. When you say, basically, he's trying to say, so this is the weakest precondition here, and this is the original precondition, right? So he was saying this WP here is stronger than the original one. That is equivalent to saying the original one is weaker than the WP. It's the same thing, really. He's really saying which set is actually larger. Okay, just a matter of style. So I would expect in the exam you have to clearly mark down which step you are trying to do. First of all, I don't see any WP here, do I? Right? So I would expect to see somehow you're jumping the steps, but that's okay since you are trying to do some demo on the class, you may not have time. So I would expect something like WP, and then you actually just copy the account that withdraw, and then you will have account balance larger than 0. That's the first line I would like to see. And then you would say this line can get to here simply because I want to see the reason here. And apparently you forgot about the equal sign for each one of them, right? So now for the equal sign here, so we'd say that's a rule for the WP for assignments. So that's why you can do the substitution. That's pretty good. However, inside the square brackets, you have to say what should be substituted by what. So here, so somehow you want to say this is the post. I think you got this actually wrong. Okay, so this part here should be the post condition.
Oh my God.
So ACC balance. So that's post condition here, larger than 0. And what should be the substitution? So that should be ACC dot balance is substituted by, I'll show you the solution in a moment. So this should be basically the balance minus amount, right? And then you actually do the reasoning above, as below. Okay, so try to improve that. So although your final result is correct, simply I will also focus on your reasoning steps. Okay, so for quiz, so I do see the WP, that's good, pretty good. However, I don't see the post-condition here, because remember, WP takes two arguments, right? So it takes, the first argument is absolutely correct, although here for the balance, you have to say ACC about balance, because we are talking about object, feature call.
It's so short.
Okay, so here you have to say what the post-condition is, and then, of course, this will be the rule for that. So now you would say balance is substituted by O balance minus amount, that's really good. So now, balance. So now the post-condition there would be, actually this should just be a copy of that, right? So that would be a post-condition substituted by the substitution you have. So here, this should be, so the post-condition should be ACC balance larger than 0. Yeah. Okay, and then you do the substitution. So you'll get something out false actually. When you read the solution, you will see why. Okay, you do get some idea how I'm actually going to create your paper. So please try to practice and try to comply with this style. Okay, let's see. So this would be the solution. Okay, let's go over that. First of all, I want to see that's the implementation here. So that's here, first argument for WP. That's the post condition we have. And then the second argument for WP. The reason is now we want to unfold the definition for withdrawal. And also the current object is ACC. That is why we can substitute current by ACC. So we get the ACC by balance. So now
What's the
we have
DEF means? What's the DEF?
definition.
Oh.
Definition.
Oh.
No, I mean, okay, no.
So here we have, so this is like an unfolded definition for withdrawal. So AC to the balance is assigned to be AC to the balance minus amount to establish the post condition the same. So now, to go from here to the next step, we're going to apply the, first of all, let's substitute all the O values for balance by counterbalance 0. That's O value first. So you can see that. Oh, I missed that. Okay, there should be something here. Sorry, I forgot to put that. I'll put that when I post the slides. Yeah, that's apparently wrong. Yeah, but you know, I'm not going to take the exam, so that's okay. But if you miss that, you will get some marks deducted. That's for sure. Right. So that's the post condition we'll get to what we're trying to establish, and then we'll get the we'll do the substitution. Okay, that's what you would get eventually. Okay, and that's the first step. And the second step is you're going to compare this with the original precondition here. So one is greater than, the other one is greater than or equal to. So you can see that the weakest precondition happens to be stronger than the precondition you have. That's not good. Okay? It is not the case that the precondition you have implies the WP. So, no, that's not correct. So that would be the standard answer I would expect from you, except for the missing step, of course. That's something I will update when I post the slides. Any questions about this exercise? Yes.
That last part, do we have to say that like as a conclusion? After the bottom there.
On here?
Do we have to say?
Well, you have to somehow to say, because that's the first step, which is for you to get the weakest precondition for this particular implementation and post condition. And now once you get it, you have to somehow to say, you want to have some comparison between this thing and the original precondition.
I guess the question is, do we have to do it formally, or should we just write like a sentence?
Well, if in this case, it would be acceptable if you simply say, yeah, that's actually stronger. Yeah, that'll be okay. Yes.
So after substitution and simplification, we simply get the same thing as we had in the precondition.
No, because you can see that it's greater than, and now it's greater than or equal to. So you can see that this guy here is actually stronger because it does not include the possibility of being equal to.
And then if it's not the case, then it applies.
Yeah, so to be correct, the precondition here must imply the weakest precondition. But in this case, it's actually reversed. It is the weakest precondition that implies the original precondition, which is not one. Let me try to simplify the procedure for you. Hopefully that will be easier to memorize or to understand. So let's say, actually, let me just rephrase the rule again, slightly easier. So step one. Calculate WP S with respect to R. Okay, that's step one, exactly what I did there. What's step two? And you prove that Q is actually stronger than WP, stronger than or equal to. If you can, then that's correct. Otherwise, it's not correct. So in this case, Q would be larger than or equal to. And WP would be the greater than. Of course, the implication doesn't help. That's why it is not correct. Yeah? Okay? Can we go on? Yes.
Let's say the amount is negative, since you're gonna have a precondition which is the amount has to be greater than 0. You're still gonna do the thing, the first condition is gonna fail.
Sorry, say that again.
If the amount is negative, the amount is negative 5 or something like that, and your balance is 10, then your court is letting that case to pass.
If amount is, well, actually, if amount is negative, that's okay. That means you're trying to minus something that's negative, which means you're going to increment that. Of course, it's going to be greater than 0.
Yeah, but that is wrong.
Well, you know, as far, okay, that's good. As far as the post condition is concerned, we only want the final balance to be greater than 0. As far as that is concerned, it's correct.
Yeah, but
You might need more. You might need more post condition to actually catch this. That's my point. But that's a good thing. Okay, so any more questions? Okay, try to do the exercise. We actually have covered quite a few.